What if the chatbots your company uses today, the ones your engineering teams just spent the last 2 years painstakingly integrating and fine-tuning, what if they are already completely obsolete?
I mean, it's a pretty sobering thought for any CTO or developer listening right now,
Yeah.
because we are looking at, honestly, a fundamental rewiring of enterprise infrastructure.
Yeah, exactly. I was going through the 2025 Gartner AI Infrastructure Trends report, and a specific statistic just practically jumped off the page.
Oh, the adoption rate one?
Yes. So by 2026, 67% of enterprise organizations will have adopted multi-agent systems in at least one business function.
Wow.
Right. And that is a massive jump from just 23% in 2024. We are no longer talking about like early adopters tinkering in sandboxes. We are talking about the majority of the market rolling this out to production. So, okay, let's unpack this.
Yeah, let's do it. Because the underlying driver here is that the era of reactive, isolated chatbots has basically hit a ceiling.
Right. They can only do so much.
It's exactly. For the past few years, organizations have been bolting these conversational interfaces onto their databases and, well, calling it an AI strategy. But those systems only act when they are acted upon.
Right.
The architecture that Gartner is tracking, which is becoming essential infrastructure by 2026, is Agentic AI.
Agentic AI.
Yeah, Agentic AI. This shifts the enterprise operating model from a passive response to active workflow automation.
Yeah.
And for anyone operating in Europe, adopting this architecture is deeply complicated by the stringent compliance demands of the EU AI Act.
It's just a whole other beast.
It really is. So our mission for this deep dive is to map out what agentic AI actually is, the underlying mechanics of multi-agent networks, and crucially, how technical leaders can deploy them without triggering catastrophic regulatory fines.
Right, because nobody wants a fine. So to understand that 67% adoption stat, we need to draw a hard line between a traditional chatbot and an agentic system.
Definitely.
I tend to think of a traditional chatbot as like a digital vending machine. It's entirely reactive, right?
That's a great way to put it, yeah.
Yeah. You press a button, you input a prompt, and the system dispenses a static output. And if the user doesn't initiate, the system just sits dormant in an idle loop forever.
Exactly. The contrast with agentic AI is autonomy and goal orientation. An agentic system does not wait for a granular, step-by-step prompt. You just assign it a high-level objective.
Like, solve this problem rather than do these 5 steps.
Right. The system then utilizes its reasoning engine to break that objective down into a multi-step execution plan. It relies on persistent memory to maintain its state. It accesses external tools independently, triggers APIs.
Wait, so it's actually acting on its own?
Yes, and critically, it observes the environment to verify if its actions moved it closer to the goal, and then it learns from the outcomes.
Okay, so sticking with the analogy, if the chatbot is a vending machine, agentic AI is like hiring a highly proactive floor manager.
That is exactly the shift.
Like if your customer has a shipping complaint, a traditional chatbot just says, "I'm sorry, here's a link to our refund policy."
Yeah.
It requires the human to execute the next step.
Right, very frustrating.
But an agentic system takes the context, queries the order database, pings the third-party logistics API to locate the lost package, and then automatically issues the API call to Stripe to process the refund.
Exactly. That is the architectural leap. The agent handles the end-to-end workflow by itself. However, I should note that that level of independence operates on an autonomy spectrum.
Right, they aren't all fully autonomous right out of the gate.
No, not at all.
Yeah.
We categorize this from level 1 to level 4. So level 1 involves the agent analyzing data and merely suggesting an action to a human operator.
Okay, pretty safe.
Yeah. Then level 2 allows the agent to execute heavily constrained, low-risk tasks autonomously. Level 3 introduces independent operation for complex tasks, but it enforces periodic human review.
Got it. And then level 4.
Level 4 is a fully autonomous, closed-loop system. It's executing high-stakes decisions without a human in the loop at all.
Wow. And level 4 is where we cross from like a technical challenge into a massive regulatory liability.
Oh, absolutely.
Because when software starts making unreviewed decisions that affect consumers, the risk profile just explodes. But before we get into the legalities, let's look at the actual architecture, because the source material heavily emphasizes multi-agent systems.
Yes.
If one autonomous agent is a proactive manager, having dozens of them introduces a whole new layer of complexity.
It does, because complex enterprise workflows just cannot be solved by a single monolithic model.
Yeah.
A multi-agent system is basically a distributed network where specialized, narrow-scope agents operate concurrently toward interdependent goals.
So let's break down the technical enablers making that possible. We know large language models provide the core semantic reasoning, but how are these systems actually executing secure enterprise tasks?
Right, that's the big question.
I'm thinking specifically about retrieval augmented generation, or RA, because if we are giving these agents access to proprietary company data, how do we ensure our internal financial documents don't just, bleed into the training data of a public model?
Well, the architecture actually separates the reasoning engine from the knowledge base. RJ functions as a secure retrieval layer entirely within your enterprise boundary.
Okay, so it stays locked down.
Exactly. When an agent needs information, it queries a secure vector database containing your proprietary embeddings. It pulls only the relevant context, injects it into the prompt at runtime, and the LLM processes it transiently.
Transiently, meaning it forgets it right after.
Yes. The proprietary data never becomes part of the LLM's underlying parametric memory.
Okay, that makes sense. The data stays walled off. So we have the LLMs for reasoning, RG for secure knowledge, and then tool integration, meaning the agents can fire off PST requests to internal APIs.
Right.
But managing all this simultaneously requires orchestrating chaos. I picture this like a high-end restaurant kitchen.
I like that.
You have specialized agents, right? A sous chef parsing data, a grill master executing API calls. If they aren't communicating constantly, the whole system crashes. The tickets sliding along the rail in the kitchen are essentially the message queues and API payloads.
That's a really solid way to visualize it.
And if the expediter loses a ticket, the entire service halts. I guess my question is, without a head chef, doesn't this just result in total chaos?
Well, the expediter, your analogy, is the orchestration framework. The sources actually provide a highly detailed e-commerce use case that maps directly to this.
Oh, perfect.
Imagine a demand forecasting agent analyzing market trends and predicting, say, a massive spike in winter coat sales.
Okay.
It generates a message payload and drops it into a queue for the procurement agent. The procurement agent reads the payload, checks warehouse capacity via your inventory API, and issues purchase orders to suppliers.
All on its own.
All on its own. Simultaneously, a pricing agent observes the new supplier costs and dynamically updates the retail pricing on the front-end storefront. Finally, a customer service agent is primed with this new context to handle the inevitable influx of consumer inquiries.
Okay, but wait. Without a human overseeing every state change, how do you prevent cascading failures? Let's say the forecasting agent hallucinates a trend and tells the procurement agent to order 10 million winter coats.
Which would be a disaster.
Right. If they're just firing off APIs autonomously, that could bankrupt a business in milliseconds.
So the orchestration layer enforces strict governance protocols. Agents do not just broadcast commands into the void. They operate under confidence thresholds and utilize a centralized coordinator agent.
Okay, so there is a boss.
Yes. The coordinator's sole function is routing tasks, monitoring state changes, and resolving conflicts. If the forecasting agent generates a request to order 10 million units, that anomaly falls outside the predefined historical variance parameters.
So it catches the mistake.
Exactly. The coordinator agent flags the confidence score as critically low, halts the specific API execution, and escalates the payload to a human dashboard for manual review.
Ah, I see.
And the rest of the system continues to function, but that specific workflow is quarantined.
So you have a robust fallback mechanism built into the message queue. That brings us to the operational reality for the CTOs listening. Transitioning from sequential human-driven processes to this kind of parallel, multi-agent architecture requires a massive overhaul of back-end infrastructure.
It's a huge undertaking.
So why are organizations racing to implement this by 2026? Like, what's the rush?
The ROI. The efficiency gains render older operational models basically non-competitive. Organizations deploying multi-agent architectures are documenting 30 to 50% efficiency improvements across core business functions.
30 to 50%? That's incredible. And the Forrester 2025 data backs that up with some astonishing numbers.
Yeah, what does they find?
A major financial firm deployed a multi-agent system to handle customer service automation, and they achieved a 43% reduction in operational costs.
Wow.
But the truly disruptive part is that their first contact resolution rate actually increased from 62% to 84%.
That's massive.
Right. These multi-agent networks are autonomously resolving 80 to 90% of all customer interactions without ever routing to a human.
And the back office applications are arguably more impactful. Look at the pharmaceutical sector. Submitting a new drug for regulatory approval traditionally requires teams of researchers, lawyers, and compliance officers spending weeks manually cross-referencing clinical data against regional laws.
Sounds like a nightmare.
It is.
Yeah.
But multi-agent systems run this concurrently. One agent aggregates the technical clinical trial data. A secondary agent cross-references that data against the European Medicines Agency compliance database.
Wow, at the same time.
Yes. A third agent drafts the formal submission, while a fourth specifically scans the drafted text for legal liabilities.
And a process that used to take 3 weeks is suddenly compressed into, what, a 40-hour compute cycle?
Exactly.
That is an insurmountable competitive advantage for the companies that get there first. And this underlying back-end speed is totally changing the front-end user interface, too.
Right, because the user experience has to keep up.
Exactly. Looking at Google Trends data from 2024 to 2025, searches for AI chatbots grew by 64% year over year. But users are suffering from text box fatigue.
Oh, absolutely.
They want immediate resolution without typing out paragraphs of context. The sources emphasize that by 2026, user interaction will be dominated by voice agents and multimodal AI.
Voice has evolved into a frictionless interface because the underlying latency has dropped to near human response times. We are not talking about legacy IVR systems where you scream "operator" repeatedly into the phone.
All right, we've all been there.
These modern voice agents manage complex, multi-turn dialogue trees. They retain conversational state over long durations, and this is a while-genus acoustic features to detect user frustration or urgency.
Oh, wow. So if a user calls in and their vocal cadence indicates high stress, the system detects that biometric marker and dynamically adjusts its prompt instructions to respond with a calmer, more empathetic tone.
Yes, exactly. While invisibly coordinating with the back-end agents to pull logistics data at the same time.
That's wild. Multimodal interfaces push this even further, don't they?
They really do.
Like, a user could point their smartphone camera at a malfunctioning industrial pump. The visual AI model processes the video feed, identifies the specific microfracture on a valve, and the voice agent audibly guides the user through the recalibration process in real time.
The fusion of visual processing, voice interaction, and back-end agentic orchestration creates an incredibly powerful tool set. But this introduces a critical friction point.
Right. Because if a voice agent is analyzing a user's vocal stress, it is collecting biometric data.
Precisely.
And biometric processing by an autonomous decision-making system inside the European Union is a massive regulatory tripwire.
Yeah.
We cannot talk about multi-agent systems without confronting the EU AI Act.
Exactly. If we connect this to the bigger picture, we run into what I call the agentic paradox.
The agentic paradox.
Yes.
Right.
The very characteristics that make agentic AI so powerful, its autonomous reasoning, its ability to formulate novel execution plans inside a neural network, are the exact things that conflict with European law.
Oh.
Right. Under Article 6 of the EU AI Act, Level 4 autonomous agents deployed in critical sectors frequently classify as high-risk systems.
And classifying as high risk isn't just a label, right? It triggers a cascade of mandatory technical requirements. The Act outlines 4 severe rules. Let's look at explainability first. How do you actually achieve that?
It's extremely difficult.
Because neural networks are inherently black boxes. If an autonomous pricing agent suddenly denies a European vendor a volume discount, the company can't just tell the regulator, well, the algorithm decided, we don't know why.
The regulators will levy massive fines for that response. Explainability in a multi-agent system means you must engineer deterministic logging into the orchestration layer.
Meaning what, practically?
The system must generate a human-readable audit trail that traces the exact decision tree. Which vector in the RA database did it pull? What was the confidence score? What specific API payload was generated? It is about making the black box transparent through exhaustive state tracking.
Which flows directly into auditability. You need an unalterable, tamper-proof record of every data query and action.
Exactly.
Then there is the requirement for interruptibility. And this one is tricky. If a system is running parallel tasks across 4 different departments, how do you pull the plug safely?
You engineer a literal kill switch at the API gateway level. The Act mandates that a human operator must be able to halt or override an agent's actions in real time.
So if things go wrong, you can just stop it.
Yes. If the multi-agent system begins a cascading failure loop, the orchestrator must allow a human supervisor to sever its access to external tools instantly without crashing the legacy databases it connects to.
That sounds incredibly complex to build.
It is. And finally, you have continuous bias monitoring. The system cannot produce discriminatory outcomes based on the user data processes, which actually requires deploying separate, specialized agents whose only job is to audit the primary agents for statistical bias.
So you need AI to watch the AI.
Basically, yes.
If an organization fails to embed these controls, the financial penalty is devastating. The maximum fine under the EU AI Act is up to 6% of global turnover.
And that is top-line revenue, not profit.
That kind of penalty is an existential threat to a business.
Which is the core takeaway regarding implementation. You cannot architect a brilliant, fully autonomous multi-agent system, get it ready for production, and then ask the legal team to bolt EU AI Act compliance onto the finished code.
It's too late by then.
Way too late. Auditability, explainability, and interruptibility must be foundational engineering prerequisites.
So let's put ourselves in the shoes of a CTO listening to this right now. You are staring at the massive ROI of efficiency gains on one hand and the terrifying prospect of a 6% global revenue fine on the other.
It's quite the dilemma.
How does a technical leader actually navigate this safely? What is the practical playbook for deployment?
The playbook relies on a highly structured, phased implementation path. Organizations failing with AI right now are the ones trying to rip and replace their entire backend in one sprint.
Too much, too fast.
Exactly. Phase 1 is the pilot. You stand up a single agent in a low-risk internal domain, such as an IT help desk bot querying internal documentation via RH. Crucially, you constrain it to level 1 or level 2 on the autonomy spectrum.
So every action requires a human sign-off.
Right.
And once the infrastructure team proves the RHA pipeline is secure and the logging architecture meets audit standards, they move to phase 2, which is expansion. This is where you introduce the orchestration layer and have 2 or 3 agents pass payloads to each other.
Perfect, yes. Then phase 3 is optimization.
Hmm.
Here, you cautiously dial up the autonomy, moving into level 3. The engineering focus shifts heavily to the human handoff protocols.
What does that mean technically?
Technically, this means defining the exact confidence thresholds in the code. If an agent's certainty drops below 85%, how does it package the conversational context, the system state, and the API history, and seamlessly route that payload to a human operator's user interface without dropping the session?
Ah, I see. And then phase 4 is full integration, where multi-agent networks become the default operating model. But realistically, the build versus buy dilemma here is intense.
It really is.
Engineering a fully compliant orchestration framework, building vector databases for RAG, and ensuring real-time interruptibility from scratch is incredibly resource-intensive. If your infrastructure team gets the compliance architecture wrong, the company takes the hit.
And that risk profile is shifting enterprise strategy towards specialized vendor partnerships. You need partners with an API-first architecture whose platforms have EU AI Act compliance baked into the foundational code.
Right.
The source material specifically highlights AetherLink as a model for bridging this gap. They have structured their product suite to solve this exact transition.
Right. They divide the problem into 3 distinct vectors. You have EtherMind, which tackles the strategy and compliance front. They audit the architecture to ensure the governance framework actually aligns with the legal mandates before a single line of code is written.
Essential step.
Then there is AetherDV, which is the heavy lifting building the custom multi-agent orchestrations, the secure RAG pipelines, and integrating them safely into legacy enterprise systems.
And for the user interface, they deploy AetherBot. This solves the front-end problem by providing production-ready, compliant conversational AI.
Oh, nice.
It gives enterprises access to those advanced voice and multimodal capabilities we discussed, but the compliance logging, state management, and interruptibility mechanisms are already engineered into the platform. It mitigates the risk of building complex interfaces from the ground up.
So it basically provides a structured, legally sound pathway from legacy operations to an agentic architecture.
Exactly.
Because ignoring this shift until 2026 is no longer a viable strategy.
Not at all.
All right, this has been an incredibly dense, highly technical deep dive into the future of enterprise infrastructure. To distill everything we have covered down to the absolute core, what is your #1 takeaway? I will start.
Go for it.
For me, it is the sheer magnitude of the operational leap. We are not just talking about software that writes emails faster. We are talking about moving from sequential human processing to parallel autonomous execution.
Yeah.
When Forrester reports 30 to 50% efficiency gains, it is because you have an architecture where 4 specialized agents are executing the workflows of 4 distinct departments concurrently in milliseconds with perfect data synchronization. It completely redefines the speed limit of an enterprise.
I agree. The operational speed is staggering. My primary takeaway, however, focuses on the friction point. Governance is no longer an abstract legal concept. It is a hard engineering requirement.
That's a great point.
The capabilities of multimodal AI and complex reasoning engines are seductive, But under frameworks like the EU AI Act, if you cannot achieve deterministic explainability and real-time interruptibility, the system is illegal to operate. Security and compliance must dictate the architecture from the very first sprint.
Wow. I think that leaves us with a fascinating and slightly unsettling final thought for everyone navigating this transition.
What's that?
If we are moving toward an architecture where autonomous agents are concurrently responsible for supply chain procurement, dynamic pricing, and direct customer resolution, basing their actions entirely on massive real-time data synthesis, how will your leadership team define intuition?
That is a tough one.
What happens in the boardroom when the multi-agent system generates a perfectly logical, data-backed execution plan that directly contradicts the gut feeling of your human executives? In a fully agentic enterprise, who do you trust?
A profound question that every technical and business leader will have to answer very soon.
For more AI insights, visit etherlink.ai.